Sensitivity and specificity are fundamental concepts in epidemiological analysis used to assess the performance of diagnostic test or screening measures. These measures help evaluate how well the test can correctly identify individuals with the disease and those without the disease. Let's explore this concept using an example. Imagine a new diagnostic test for COVID-19 called Test X. The test is designed to detect the presence of the virus in individuals suspected of having the disease. First, we should know what is true positive, false negative, true negative, and false positive. True positive means individuals who have COVID-19 and test positive with test X. So, in this case, our true positive value is 4. False negative. Individuals who have COVID-19 but test negative with test X. So, in this case, false negative is 1. True negative means individuals who do not have COVID-19 and test negative with test X. So, in this case, true negative equal to 90. False positive means individuals who do not have COVID-19 but test positive with test X. So in this case, false positive equal to 5. Sensitivity measures the proportion of individuals with the disease who are correctly identified as positive by the test. This is the equation for sensitivity. Number of true positive equal to 4. Number of false negative equal to 1. So, 4 divided by 5 equals 0.8. Specificity measures the proportion of individuals without the disease who are correctly identified as negative by the test. This is the equation for specificity. Number of true negative equal to 90 and number of false positive equal to 5. So, 90 divided by 95 equals 0.947. Finally, we got 0.8 as sensitivity and 0.947 as specificity.